Okay, so this is the last lesson of the semester. After this, we're going to review for 2 days, take the last test of the semester, well, the last semester test, the last unit test. You guys, I'm going to be real clear again, we're not doing corrections for the last test, so you guys are going to have to just dominate on this test. That's another reason why I've been doing bell work where we're factoring, because that's what the whole test is about. You just have to factor. But the last lesson, the one from yesterday, was about cross multiply. Now, in order to cross multiply, the problems have to look a certain way. You have to have one fraction on one side and one fraction on the other side, and the equal sign has to be in the middle. Today, what we're going to do is we're going to take a look at problems that have too many fractions to cross multiply. So, for example, 1 over x plus 2 plus x over x plus 2 equals 2 over x plus 2. So this problem cannot be cross-multiplied because it's got too many fractions. If this fraction right here, if this one was missing, we could have cross-multiplied, but it's not balanced. You've got two fractions on one side and then a fraction on the other side. So the way that we attack these problems, and I don't know if you noticed, but I did this on purpose, look at the bottoms. They're all the same already, right? So if they're already the same, we don't really have to pay attention to them. All we have to do is work with what's on top. And that's common in a lot of different math problems. In the last chapter, for example, we had a problem. It was something weird like this. Let's see. x5 equals xy. That was on the last test. You were supposed to find out what y was equal to. And that problem wasn't supposed to be super difficult. All you had to do was make it so that there were fractions on one side. So you have like x to the 1/2, and then we convert this. This becomes x to the 5/2. Once they're both fractions, you can now subtract these things. So you would have 1/2 minus 5/2, because that's what happens when you have two bases that are the same. You can subtract the fractions. So this would give you x to the negative 4/2, which is negative 2. And then you just bring this other piece back down, x to the y. And we said back in that chapter that when the bases were the same, you could just ignore them and solve what was in the exponent. So the answer to this would have been y equals 2. That same kind of concept is used here. These still give us our restrictions, but once we get the restrictions, we don't need these anymore. We can just solve whatever is on top. And that's going to be our strategy for today. We're going to find the LCD. We're going to change the fractions so the bottoms are all the same. And then we're just going to work with what ends up on top. So that's where today's notes are going to start. So when it comes to these problems, you can see there's 1, 2, 3 fractions. So that's when we have to do it this way. So I'm going to take these fractions, and I'm going to figure out what the LCD is. Now, since I have 3 fractions, I'm going to have 3 levels to my LCD work. The first fraction has a 2 at the bottom, and that 2 is already prime. So I just put the 2 right here. The second fraction has an x at the bottom. That is also prime. So I go down a level, and I put the x right here. The final fraction also has a 2, which is prime. So that goes in the third level, right underneath the 2. So our LCD is 2x. Now, if our LCD is 2x, what's the restriction? Yeah, it's going to be 0. Anytime you have an LCD that doesn't have parentheses, the restriction for that value is always going to be 0, as long as there's still an x there. If the x was missing, we wouldn't have restrictions. But this one, x cannot be 0. Okay, so since we found the LCD, we are going to rewrite this fraction with this new denominator. So what that entails is trying to figure out what to multiply the fraction by so that it's its unreduced form of itself. So they're still going to be equivalent. So if you look at the first fraction comes from this first level of our column work. It's missing this. So that means this one has to be multiplied by x. So 1 times x is just x. Or you can leave it as 1x, I don't care. And you can kind of see already. If we cross out those x, it is 1/2. They're equal. The second one has an x on the bottom, so that's this one right here. That's missing a 2. So we would multiply this by 2. So the top of the next fraction would be a 6. Then our last fraction is missing the x. So we would have to multiply this one by x. So that will leave us with x squared here. Now you guys see all the signs that are attached to the fractions or in between fractions? We have this one, and we have this one. All I'm going to do is, instead of having it like in the middle of the fraction, I'm just going to move them up, because we're about to get rid of all the fractions right now. So the minus in between here goes up here. The minus over here goes up here. Now we don't have to worry about the bottoms. So we have 1x minus 6 equals negative x squared. How do we solve a problem that has an x squared in it? That's what everyone always says. But you guys have to be careful, and you have to look at the whole problem, because it has an x squared, but it also has an x. We don't square root these problems when they have 2 different types of x's. Yeah. So the whole thing is, if you ever see an exponent, you need to make sure that your problem is equal to 0. So we're going to take this x squared, and we're going to add it so it goes to the other side. And I'm specifically moving that one because we don't like to have negatives on our x squareds. So we're going to end up with x squared plus 1x minus 6. Now it's just an ABC problem. So our simple ABCs. Find the list of numbers for 6 that add to 1. 3 and 2. To make it a positive 1, it's going to have to be positive 3 and minus 2. So we just put our x's right here, and this is equal to 0. Once we have it factored, then we take that extra step and actually solve it. Set each one equal to 0 and solve for x. So this one would be negative 3, and this one would be positive 2. Those answers, they're not extraneous because they don't match the restriction up above. And if you don't believe me, you can go plug them in yourself. But I'm telling you, the only time it's not going to work is when there's a restriction. When we're doing these fractions, all the answers work except for the ones that match your restrictions, like we already talked about. So we got another one. The only difference in this one is it has a minus sign, so that means that we use parentheses. And when we do these problems that have parentheses, that just means that we need these to be wider. Now this problem, again, it's made up of 3 parts. It's got this one fraction, it's got the 1, and then it's got the other fraction. So we can't cross multiply this one. So the strategy for this times is make the bottoms the same and then just ignore the bottoms. So the bottom of this one cannot be factored. So that means the first level is x minus 2 in parentheses. The 1 technically is over 1, and that's prime, so we're going to just put a 1 at the second level, and I screwed it over because it doesn't match the parentheses. And then the third one would go underneath x minus 2 on the third level. So our LCD for this one is just x minus 2. Do you guys know why I'm ignoring the 1? Yeah, if you just do 1 times anything, the 1 goes away. So I don't usually write the 1. So our LCD is that, so that means our restriction, x cannot equal 2. So we're going to take these 3 parts of our problem and turn them into 3 fractions, all that contain an x minus 2 at the bottom. Because Because if the bottoms match, then we can just ignore the bottoms and work with the tops. So now it's a matter of figuring out what to multiply by. What do we multiply the first one by? Yeah, so it's missing this one right here. So it's got to be times 1. So that's 2x. What would we multiply the second one by? The entire x minus 2. Now, 1 times x minus 2 is just x minus 2, so I'm going to just leave it like that. And you can kind of see right here, if I have x minus 2 over x minus 2, they would cross out and give me 1. So it is still equal. And the last one, what do I need to multiply the last one by? Yeah, 1 again. It's this one that's missing. So times 1, so that's 4. Now all of my signs in the original fraction, all I do is just move them higher. So in the front there's nothing, in front of the 1 there's nothing, but right here there's plus, I just put it up here. So now that's my real problem. 2x equals x minus 2 plus 4. It looks like I can combine like terms right here. So I have x plus 2 equals 2x. So on these types of problems, we don't set them equal to 0 because there's no x squareds, no exponents at all. So on these ones, we want to separate the x's from the numbers. So I take the x and subtract it over. So I end up with x equals 2. There's a problem, right? That was our restriction. So when you get an answer that is the restriction, we say that's extraneous. So we still write it down, we just write extraneous by it, or next to it, or near it. So the only time you have extraneous is when it matches your restriction. Now if you guys, if you were to like use a textbook or some sites on the internet, if your only answer is extraneous, sometimes they put no solution. But me, I don't want that. I want you to solve the problem, tell me what the number is, and then tell me it didn't work by writing extraneous. So don't give me none of this no solution nonsense. I want to know the work. I want to know it all. The reason why is because there's kids sometimes where they don't know how to do the problem, and then on the test they write no solution 5 times. Guys, we're never going to give you a test where there's no solution 5 different times. So just make sure you actually solve it, give me the number, and then tell me that it was extraneous. Now, I also I want us to review a lot for the final. And I'm going to give you guys some incentives later that I just need to run it by my Algebra 2 team so where you can really improve your grade if you do really well on the final. So the plan is we're going to scrap the 7.5 homework. So in the homework packet, you don't need to do 7.5. You can just recycle it. What we're going to do instead is we're going to do the review. We're going to spend 2 days on the review. So today and Friday is review day. Then on Tuesday, we're going to take the last test. No corrections. You get what you get. No, I meant Wednesday. I mean Tuesday. Next Tuesday. Sorry. Then we're going to have Wednesday, Thursday, Friday, Monday, and Tuesday. 5 days to review for the final exam. The final exam is only 30 questions. The review for it is 100. We have 5 days, guys. Calm down. We're going to break it up into chunks. All you have to do is become a professional at a certain amount of problems each day, and you will be prepared for the final. And I think you're really going to like the incentive because there's a chance, like if you could pull up your grade a couple of letter grades if you do good enough on the final. But we'll talk about that once my team agrees. So I'm going to pass out the review, and then the rest of the time is yours to practice. Oh, and also, in first hour, I decided to scrap 7.5, so I actually haven't recorded the review for this yet. So there is no review for this on YouTube just as of right now.